Hi everyone, welcome back. Today we are going to see about the EMF equation of single phase transformer. So in a transformer, the source of alternating current is applied to the primary winding. So in transformer, there are two different types of winding. One is nothing but primary winding, another one is called secondary winding. The primary winding which is connected with the source and the secondary winding which is connected with the load. So when the primary winding is connected with the source, while supplying the alternating current to the primary winding is getting energization. So that is called, during this energization, it produces magnetic flux in the core of the transformer. This, because of the production of flux due to the alternating current, the produced flux is also an alternating flux. The flux is also get alternating with respect to the time. So the produced flux that will be linking with the secondary winding through transformer core. This phenomena is called mutual induction, which is the EMF will be induced in the secondary winding because of due to this principle. The EMF will be induced in the secondary winding. So the magnitude of induced EMF can be found by using the following equations. So here, this is a general operation. So this is nothing but a transformer core, and this is a transformer core, and primary. This is a primary winding, and this is a secondary winding, which is connected with the source and which is connected with the load. Okay, I1 into V1 indicate primary voltage, I1 is nothing but primary current, V2 is nothing but secondary voltage, I2 is nothing but secondary current, E2 is nothing but induced EMF in the secondary, N1 is number of turns in the primary, N2 is nothing but number of turns in the secondary, E1 is nothing but number of the EMF induced in the primary. Okay. So here the input voltage is sinusoidal. So therefore the produced flux is also sinusoidal. So what is T? Okay, so T is nothing but the time taken to complete one revolution is called time period. The time taken to complete one revolution is called time period. So it has positive half cycle as well as the negative half cycle. Okay, so the total time period is T. So here half is nothing but T by 2. Here it is nothing but T by 4. So this is indicate flux. So when the flux is maximum at 90 degree. That is nothing but T by 4. Okay, so let N1 is nothing but number of turns in the primary winding, N2 is nothing but number of turns in the secondary, and pi m is nothing but the maximum flux. Pi m is nothing but the maximum flux at the time of T by 4. Okay. So now already we know that the time and the frequency both are inversely proportional. Okay. So here the average rate of change of flux. So when the flux is maximum at the time of T by 4, so T is nothing but 1 by F, inversely proportional to the frequency. So pi m divided by 1 divided by 4F, so that the denominator is taken into the numerator. So therefore the average rate of change of flux is equal to 4F pi m Weber per second. Okay. The induced EMF per turn, only we are considers only one number of turn. So therefore the rate of change of flux per turn, which is equal to the same one, 4F pi m. Okay, if you then already we know that the form factor, which is equal to RMS value divided by average value, which is equal to 1.11 for sinusoidal waveform. Okay, so therefore the RMS value is equal to form factor into average value. So already we know that form factor is equal to 1.11 into the average value 45 FM. So while multiplying, we are getting 4.44 F pi m. Okay, so this is the EMF equation, the amount of EMF which is induced per turn. Okay, now let us consider the total EMF induced in the primary winding, whole primary winding. So therefore, the same 4.44 F51 and it will be multiplied by the number of turns in the primary winding. So that the number of turns in the primary winding can be multiplied with this equation, we are getting the total amount of induced voltage in the primary, as well as while multiplying N2, we are getting the total amount of induced voltage in the secondary winding. And this is the voltage transformation ratio. The voltage transformation ratio is nothing but here the voltage transformation is nothing but here the E1. Okay, so let us consider V1 by V2, which is equal to E1 by E2, which is equal to the number of turns N1 by N2, which is equal to I2 by I1, which all are called constant K, and this is called voltage transformation ratio. Okay, and this is an assessment if input of transformer is square wave and the output will be pulsed wave, square wave, triangular wave or sine wave. So put your answer in the comment section, and these are the few references. Thank you.